Well, good morning or good evening or good something. All right, so this video is for educators who want to use origami in their geometry class, but have never seen it done or are kind of unfamiliar with how can you best, spiral as much curriculum as possible into the folding, into each individual fold. So that's what I'm going to show you right now. I know I always wanted to use origami in my classes, but I never really felt comfortable doing it until I saw someone do it, and then it kind of gave me a whole bunch of ideas. So I'm just going to show you one example. We are going to do an origami heart. I'll act like you're my class, and I'll periodically stop. Keep in mind, you could really basically stop at every single fold and make multiple teaching decisions. So I'll just highlight a couple of them. So you can get the feel, and then as you start to fold, your own origami, you'll realize as you do folds, like, oh, that's cool, or oh, I wonder if that is half of this previous size or something, and you'll start to develop your own taste. So either way, right now you're going to become my class, so welcome class. Today we're going to do an origami heart, okay? Most origami actually starts with a square, but the heart starts with a rectangle. So we are going to use a piece of printer paper. Now, does anybody know the dimensions of this piece of paper that we're going to use for the origami? What, 8.5 by 11? Yeah. Would you mind checking that for me? Can you all have your rulers with you? You mind checking to see if that's actually 8.5 and if that's actually 11? So I'm doing that because I want students to get used to the ruler, and that's the main reason, but also kind of, was it exactly 8.5? Are we okay to call it 8.5, even if it's not exact, right? Okay, so it is about 8.5 by 11. So if we got length and width, what is that ratio of length to width? What are we looking at there? And so hopefully some students are answering that. So divided by 8.5 is approximately 1.29. So this is the right dimension for the origami heart. So what if I wanted to make, say, a bigger heart? I wanted to use a bigger sheet of paper. What are some sheets of paper I could use that would have the proper dimensions for the heart? And just play around with that idea of scaling up and down, 22 by 17 and so forth. So, because you could, at the end, you could have it make a smaller origami heart if you wanted. By the way, what's the area of this paper that we're going to use? Just real quick, what's the area of this? So students might do, so now they'll get to their calculators, and 8.5 times 11. It's our area. The students will be shouting, 93.5 or something like that. They won't usually call out the units, right? So, well, what are my units? What we got? Inches squared, or square inches, which is actually a square that's 1 inch by 1 inch. So if you wouldn't mind, everybody just real quick, just go to the top left corner and just measure in 1 inch and down 1 inch and draw that square for me. And so students are, right, I just kind of want them to draw a square to remind them what a square inch looks like, right? So then they all draw that square inch. So literally what it means is, look at that little square that you drew, is that it'd actually take exactly 93.5 of those squares to cover the page, right? That's what area means. And you might ask, hey, does that seem right? Does that seem legitimate? Well, it should be 8.5 this way and 11 squares down, and so forth. Okay, so this is just a little setup because it's a rectangle. I wanted to play with ratios for a second and talk about similar rectangles and things like that. But back to the fold. Okay. All right, class, so first thing we're going to do, okay, and by the way, I don't know if there's any origami masters out there, but an origami master would never fold on the table. All folds are done in the air. So you can fold on the table if you want. I'm just throwing that out there. So the first thing we're going to do is we're going to take, say, the top, let's start with the top left, that 90-degree angle, then we're going to bisect that angle. So here's how we bisect that angle. You take the opposite side, and you're going to fold it the opposite corner, or the vertex of this right angle, and fold it over till it touches the other side exactly. Okay. There we go. Fold it over like that. So this fold we just did is called a valley fold. So a valley fold is every time you fold towards yourself, because when you open it up, it looks like it's a valley. If you fold away from yourself, it's called a mountain fold. So we just did a valley fold right here, and we got this shape. Well, what is this shape? By the way, what do people see? What do we call this shape right here that we got? It's a triangle. Is it, it's an isosceles triangle. Is it a right triangle? Yeah, it's an isosceles right triangle. Great. So I'm just curious, what's the distance from there to there? What's the dimension of that triangle? Now, a lot of times with students, I'm drawing, right? So, I might erase some of this at some point, but I'm usually kind of sketching. If I ask them a question about the geometry, a lot of times I'll just sketch it really quick. And I'll say, well, so what's that dimension? And the student's like, well, it's 8.5, right? 8.5. Yeah, that's great. So this is also 8.5. Can you measure it for me? Make sure. Okay, now can you measure this diagonal, or the hypotenuse of the right triangle, or the diagonal of this kind of square if we had done the bottom fold? But can you measure the diagonal of this right triangle? So they measure it, and it's, they're saying it's about 12 inches. Okay, so this is what I want everybody to do. I want everybody to grab your calculator. Let's all do this together. And why don't we type in 8.5 times the square root of 2 and see what that's about equal to. And so they see that's approximately 12. All right. So my class, we'd already, for me to do this, I usually set up the 45-45 right triangle pretty early in the class, so they already knew this relationship, so I'm verifying it. So I'd be telling kids, well, you see, we already knew that, right? We already knew that if you know a side length of a square and you want the diagonal, you just multiply the side length by root 2. And we do this just so you can see it's not theoretical. In reality, it's true. Is that close enough for us? All right. Then you could play on the fact that this measurement could never be exact and things like that. But all right, so let's open up our fold. Here they said 45-degree angle, but I might say, well, how do you know it's 45? Can we check and make sure? So they get out a protractor and they measure that angle. Generally with origami, I stop a lot the first couple folds, and then I just finish the whatever it is. Okay, so now what we're going to do is we are going to bisect the other side. So bisect the other angle. Actually, I said side, I meant angle. So we're going to go to this angle up here and take this side, this vertex, and fold it over to the other, like so. We're going to do another valley fold, so it's going to fold towards us. Great. And then we open it up, and you should have something that looks like this. Now here's the first kind of little challenging fold we're going to do. We're going to take these sides, we're going to push them together, okay, and flatten it down. Okay, so the sides come in, and we flatten it down. Manipulate the top just a little bit there, and we get this shape. What is this shape? What is this shape in the front? What are the different ways we can label this triangle? The student says yet another isosceles right triangle. You could ask them, well, how much smaller is this triangle than this triangle, our very first fold? What's the size difference there between this triangle and the first triangle? That's something you could do all day long. Pretty much almost every single fold is going to give you a new isosceles right triangle, and you can scale the sides, and you can do a lot with area scaling when you're doing origami. I might pause just to ask about this angle. Maybe it's the angle addition thing. By the way, what is this angle here? I can sketch it real quick for you. So right now we're all kind of looking at this shape. What's that angle gonna be? And students might go right to measuring it with a protractor, or they'll think it's 135 from adding 45 to 90. But either way, a student might say, oh, that's 135. Well, how do you know? Oh, well, that's, blah, blah, blah. Well, can we just check? Can everybody grab your protractor real quick and let's get that measurement. Let's see how close to 135 it is, or is it exactly 135? Again, I want them to use their geometry tools. So a lot of times I'll ask them to measure angles or measure, use the ruler to measure side lengths. Okay, so now we're happy about that. Oh, perfect. So the next thing we're going to do, if I can remember this step, the next thing we're going to do is, you see we got this rectangle down here. Okay, so we're going to do a valley fold, and what we're going to do is we're going to go at the midpoint of this rectangle. We're going to fold it onto itself, like so. Okay, so we're going to fold it onto itself, like so. Beautiful. Okay, just like that. Then, you see we have this isosceles right triangle. So what we're going to do is we're going to take the edge of this front flap, this front isosceles right triangle, and we're going to make that vertex go all the way and touch the top. Okay, so all the way and touch the top. And we're going to do that on both sides. So one thing you can notice now is that the fold actually folds right to the midpoint of this triangle here. So it folds right to the middle, so this side's the same length as that side. All right, so what shape? Now I'm not going to ask about area scaling, I guess, to the class, but you could say, okay, well here's yet another isosceles right triangle, so how much smaller is this triangle than the original triangle that we did? And they can keep scaling that. And then you ask, well, how do you know? And they, you can have them unfold it again and look at what the flat piece of paper looks like. A lot you can do. But what I'm going to do is I'm going to kind of play on this root 2 thing a little bit more. I'm going to say, so what is this shape here called? What do we got? What are we talking about? And then I'll usually say, it's a square. Okay, well, can you measure? Can you measure the dimensions of this square? So we'll go over here. We're kind of looking at this now, right? So we folded that up and in, so it's more like that. And we've got these midpoints here. We have this fold that comes down and straight. So what are the dimensions? And they measure them to 3 inches. Okay, it's about what they are. And I say, all right, well, what's the dimensions of the diagonal? That distance from here to here, what are we looking at? And so we measure 4.25 inches. You say, all right, well, let's all get our calculators. Let's check to see if our rule works that relates the side of a square to the diagonal. So let's all go 3 times root 2. When we do that, you get about 4.24. And again, we can talk about, well, is that close enough? Are we feeling confident that this root 2 relationship actually works? All right, and I already mentioned kind of the size thing, but it's interesting because they think of how this relates to the previous, how that relates to this. You can almost see all the isosceles right triangles, right? You got one, and now it's that size, and now it's that size, and you can go all the way back to the original size. So you can have a lot of fun with fractions. Okay, but we're going to move on. We're almost done. So that's probably all the geometry I'm going to mine from this. I might flip it over and just say, hey, what kind of shape is that? What kind of shape are we talking about? Is this a pentagon? Things like that. Usually if I see a trapezoid, I'll ask them to identify the shape. All right, so here's the next move we're going to do. We're going to take the sides, and we're going to fold it to the middle. Okay, so we're going to take this side, go to the midpoint of this rectangle. We're going to fold it right there and increase the sides. We're going to do another valley fold. Let's do that again on this side. So I just mentioned trapezoids. My ask class, well, look at that shape. What's that called? Right, so, okay, well, how do we know it's a trapezoid? Is it a special kind of trapezoid, or any other way we can call this shape out? All right, so now we're here. Got this looking pretty good. How many sides does this have? What do we call that? You can always go there. So we're going to finish the heart. We got 2 more folds. Here's the first one. Now, first thing we're going to do, actually, we're going to flip it over. Okay, so now we got the flat side. And we're going to take this top isosceles right triangle and we're going to fold it down to create that same square that we have here, essentially on the back. We'll do another valley fold, get that folded down nice and tight. All right? So one thing you notice about this flap is that it has a pocket, all right? So what we're going to do is we're going to take this vertex of this right triangle, or right angle, we're going to curl it up, and we're going to put it, we got a couple options here. Here's one option. You can just fold it till it's straight up, like so, and you can tuck it in the pocket on the next fold. So fold it up like that, just like that, and then you can take the other side and fold it up the same way. So you get something that looks like that. And then you can have them go back in now, try to open up this flap and tuck it in. So tuck that in and tuck that in. Okay, we're almost there. We got another, last thing we're gonna do is play with these flaps. Now, those also look like, do you think that's yet another isosceles right triangle? And what's the size, how much smaller is this right triangle than the original one? It might be another question you ask. So the final move is kind of an artsy move. A lot of times it's that last couple moves in origami, at least the simple ones that kind of bring out the artist's desire of what they think that shape represents. So here we go. What we're going to do is we're going to bend these flaps over. Okay, so we're going to bend the flaps over. I fold it to a sharp point there. Okay, just fold it to a sharp point. We can kind of push that over later. And usually take this little edge and tuck it under the flap and push that down, like so. Try to mimic. I'm gonna go for symmetry here. Okay, so I'm gonna try to get these sides to be the same height, at least to the best that I can. And try to do that. A lot of symmetry, so it should be really symmetric at this point. The last couple moves, I'm gonna just kind of push down the very tops just to give the heart a slightly more rounded feel. And you flip it over, and you have your heart. And you're good. You can write, I choose you. Draw a little picture of a train and hand it to somebody. Now the last thing you do with origami is you can always have them unfold it and refold it, because when you unfold it, you usually get really pretty, you always get really pretty geometric patterns in the original piece of paper. Okay, so they go back and you unfold it like so, and you can see, there is kind of the smallest isosceles right triangle that we saw, and now we can do some fraction work. Well, what's the size of this relative to the whole page? Or, it's kind of endless. You end up with a pattern. And each origami shape has its own net. All right, well, that's pretty much how you do it. You just make a fold, have the students make some observations, measure things. What do you think about this? Let's talk about the relative sizes. You get a lot of bisectors, so it's great for bringing up angle bisectors and perpendicular bisectors and midpoints and things like that. All right, well, send me a line if you want. I can make more videos with different shapes if you like, but hopefully this gets you started. All right, teachers, let's go get it.